is for SNOMED City, and anyone can use it, and it is designed to cover the needs of generating an international patient summary, an IPS. And it has procedures, a diagnosis, medications, etc. And the meeting today is to talk about open source terminology servers. To see this in practical terms, SNOWSTORM, which is the open source fire terminology server, which is part of SNOMED International. So,
Perfecto. Vamos ahí. La presentación está en inglés, yo le voy a dar en español.
the presentation is in English, but I will deliver it in Spanish nonetheless. And as Carlos has said, we do have a simultaneous interpretation. So the terminology services are the functions that are performed by softwares that interacts with the representations of a terminology to have access to information that derives from terminology. So a terminology service basically uses a terminology and it makes it available. And in this case, we're going to have a terminology service that works with SNOMED, basically takes the release files that are published as the document packages. And these files are imported into this semiological database, and the service makes all that information available as required for a client application. So basically, the service groups and the most common functions used for this. The most common one is trying to find the content. And this is the most basic of a terminology service. I give it a text, and it gives me the most similar text or contents. This is called term matching. And one of the things that's very important when we talk about a terminology service is using the subtype hierarchy. That means that it says, please search for this text, but within this hierarchy, or from this concept, give me all the children. This is what is done because SNOMED has this great hierarchical tree as a structure. And it also it uses the selected concepts by using defined relationships. It search for all the concepts related to the lungs and maybe an infection related to it, for example. Now, all of these has got to be provided by the terminology services, but it has got to be well acquainted with the terminology. So it has quite a complex hierarchy that is very powerful, interesting when searching, but it does have a lot of attributes and relationships. So it is important that the terminology services take advantage of this. And when it searches for information, it's got to bring information on the descriptions, relationships, the parents and the children. And this is very important function of the terminology services. When you want to use SNOMED, you must allow for the use of queries. And a lot of progress has been made. We will take a look at some examples. And a server does make the execution of these queries a lot easier. If you give me the context, I can put it on a table, is what the software says. Because looking in text is something that is done easily. But when you have to start thinking about a hierarchy, the defining relationships and queries, then instead of giving me a SNOMED file and put it in my system and programming all of these access, put that in a server and I use it with an API, and I really do not need to develop all of these knowledge from zero, the hierarchy, the attributes, and the queries. And also SNOMED provides mapping, which is very important to have access to. These ones are a little bit easier because it's a relational table, but some of the others are very complex and require specific techniques. So when we look at the terminology services, there is one which is access. We want to take a look at SNOMED. How can I put SNOMED within a clinical systems? I have diagnosis, I have mobile applications and symptoms. How can I put SNOMED into these applications? You first need to access SNOMED, and the easiest is doing it with a terminology service. You make all the questions and then you bring the SNOMED code from the server. Servers also include logic, from the execution of queries to the classification of new concepts and logical operations developed by the server. Sometimes you don't have to use the logic straight from the server, but a server that supports all of the logic operations for classification will simplify access because the information will be well organized. SNOMED is not just a list of terms and concepts, they are also interrelated by using a certain standard. So it's not an ontology standard, but it does have logic operations and allows for the structuring. Also, the server has got to have updating mechanisms because SNOMED is launched every single month, the international version, and every 6 months in the national versions, there is an update. So it's very dynamic. So if I connect to a terminology service and I'm working with it, in a very short period of time, there will be a new version. So the terminology services have got to include functions that allow for the updating to the new versions, and that's got to be easily done. And then there are some more advanced services, and these are newer and not so often used, but it's where the future is headed. There are customization services. For example, if you want to add a description, make small changes here and there in the terminology, and also for content development. These are services that are allowed to create new concepts, new hierarchies, new classifications. So with all of these available, then you can start thinking about how to use SNOMED. The first ones are the most important: access, logic, and updating. Well, and customization and content development are more advanced and not as critical. Creating content in SNOMED, it's not only the knowledge, because you have to undergo certain courses in order to be certified to know how to create content within SNOMED. It also has the responsibility of updating. So since it's constantly changing, we have to see if it overlaps with anything else. It's got to be activated, etc., etc. So there's quite a whole responsibility there, and that's normally done by the countries. There are no real organizations that do this, but it's totally open. It's only a matter of challenge. So these terminology services are used for different cases. For example, to capture clinical data. We have a clinical record and you want to upload a diagnosis and you use the terminology service to access it. To serve SNOMED, you use the terminology service on the back end in order to facilitate everything that you need to see. It's all going through a terminology service, but also to write queries. These queries that are used for the information of analysis, but also to have decision support rules. When you analyze, you say all of the patients with diabetes, and then the ones that also have hypertension, and that is all done through queries. It runs on the terminology and then the patient database. But for decision supporting rules, you can also say if the concept has, if the patient has a concept that says, I don't know, colon cancer, then we have to be careful at such and such procedure. That is to say, the queries are used to write rules that can give us warnings, alerts, etc. So this is very generally speaking, but let's take a look at a real example, SNOWSTORM, which is an open implementation of a terminology services, and there are other alternatives. And I can see you some web pages. You can go to snowmed.org /support, and you can take a look at the services. This is in the you go to tools or tooling. This is the SNOMED support services information for developers. And hold on, but it apparently isn't opening. It's a little bit slow, that's all. But here we have the browsers, reference set tools, mapping tools, authoring tools, and terminology services. So it's one of the categories that can be used in SNOMED. So we can click in there, and here it talks about the SNOWSTORM, and also it talks about the other terminology service. There's one in the UK called Hermes, Onto server from CSIRO, Australia, Fast, which is in France, West Coast Informatics, which is a company in the US, Snow Owl, it also has its own terminology server, and this is the example of the server in the company. But anyway, basically, this is just to give you an idea. There's no one terminology server. There are several, but they all play the same role. And most of these are paid, and this one is for free. That is the big difference. If you go to SNOWSTORM, this is the GitHub site. If you know about programming, you're probably aware of these, and there are lots of open source projects are shared here. This is the source code. It's totally open source, and this is the input. This is in Java, the CCL, and you've got the source code. This is version released 7.12. And as we were saying, then these functions, all of these terminology services have them, but this one is for free, and that's why we work with this one. And it has services that are designed firstly for SNOWMED, and then you can see that there are functions for other terminologies, but primarily it was designed to be used by SNOWMED. It's simply installed, downloaded, and it runs. It runs on Linux, it runs on Mac or Windows. You simply put it on a server, but you can simply download it and run it. And then it does have for the expression constrained language. It's one of the most difficult things. Indexing all of the database in order to have this expression constrained language, ECL. And it supports FHIR terminology services. This is very important because it talks to a standard and it's scalable, and that is provided by Elasticsearch, which is a database in SQL, which is very good for very quick and standardized searches. And it's scalable. You can use a local or Elasticsearch or one on the cloud. So there are many different ways of scaling this, whether it's horizontally or vertically. And an example of the SNOWSTORM tools that are used, it is, let's see, SNOWMED, it's edited in SNOWSTORM, and then it is extracted and shared with the user, but it's also used for the browser. This is the SNOWMED browser. Let me share it. This is the international version in Spanish, and then the national extensions, local extensions. We have all of these countries here, including Uruguay. So you could say, let's take a look at the Spanish version, and I will show how this works. I'm talking about the queries. Look, if you go to this tab, which says Expression Constrained Queries, ECL, you can click here and take a look at some examples. You wanted, for example, descendant or self-of. This means that it is a descendant or self-of diabetes. So it gives me all the different types of diabetes, 121 types. But also, and I'm doing this so that you can take a look at it. You can look at the ancestors, or you could also take a look at some concepts that have certain refinements. Let's take a look at this one. No, not this one. That's R for reverse. Let's look for a fracture, a bone fracture. Okay, foot fracture. So we can look up at the ancestors, bones. So we find bone fracture, and I put it there. And I can say descendants of bone fracture. This is, imagine yourself doing analytics. So here we can start refining because there are over 2088 here, but I can say that it has a finding. Let's see. I can look here with the different attributes, site or location of Okay. So I can find it here, and that it has a location, a site tell of for the finding, and I can put here the femur, for example. And we're going to say body structures, femur, entire femur. Let's choose this one, structure. This concept is called femur structure. So we can get that one, and I can put it here as a value. So I have 2,088 fractures in general. Can you zoom in, because we can hardly see this? Yes, of course, no problem. Okay, can you see it better there? So for it to find similar things, so we have all of these 136 concepts, which are bone fractures that are located in the femur. And you have then the possibility of creating different queries for different things. You can use the query to search for data and to have all of these codes. And then with that code, we can see which patients have these codes, or the other way around. Also, when I'm loading information, I could restrict it. If I'm a bone doctor and we want to say, all of the descendants from a fracture, or a surgeon, for example, for an endoscopy, you can say, bring me all of the endoscopy. So that gives you a more restricted search, which has to do with what you want to code, different functions for which these ECLs can be used. And then on the back end, this has SNOWSTORM. When you search here, when you look at the hierarchy and you browse through it, this is done by SNOWSTORM. This is a hierarchy, bringing the ascendant or the descendant, the parent or the child. So this is basically executing a query, and it's all done on the back end with SNOWSTORM. So this is the repository that I was just talking to you about, and there are two. One is the common, regular SNOWSTORM, and X, but it's a version for implementation. The latest things are on SNOWSTORM X, and SNOWSTORM is more stable in time. It doesn't change so often. So the idea is to start with SNOWSTORM M, and then it's migrated to SNOWSTORM. And if you want to have something that's really stable, you can use the regular SNOWSTORM. But if you want to use more of the modern functions, then you can use SNOWSTORM X. It's proven, it's tested, but it's a little bit more innovative. So SNOWSTORM, when you run SNOWSTORM, it doesn't open the browser. It's a basic SNOWSTORM is what's on the back end. It's a service, and services do not have interfaces. They create APIs. So it provides a REST API, and it has two types. One is the native, which is the Swagger, and then the Fire, which is supported by the Happy libraries. And these are two fully FIRE standardized APIs. SNOWMED International develops and maintains SNOWSTORM, and it's open source. That means that if you want to propose a change, SNOWMED can include it. Probably it will start with the X version and then the regular version, but it does not provide commercial support. So if I'm a hospital, I want to use SNOWSTORM and I want to hire someone to come twice a week to help me to do the configuration, we can do that, of course. I mean, we can provide the answer to some questions, but we cannot provide that commercial support service. I mean, any company can give. There are private companies that provide these commercial support or consulting services for the SNOWSTORM. But SNOWMED does not provide the commercial support. But what it does provide are some public snowstorms like the browser and some others that we're going to be looking at to carry out some tests. And these public snowstorms are for developers to understand how it works. But the idea is that they are not used in production because these systems can be obsolete or they're not, you have no control over them. And also there could be a misuse. They do have certain protections, and if someone is using it too often, because some don't know that you can download it with all of the contents, and they try to go through SNOMED by downloading all of the concepts with a loop, and it's not necessary because the content is for free. So it's been designed to use it more often. So if you start doing that, the system detects that there's a misuse and it kicks you out until things are clarified. So these are not servers for you to use in production, but only to carry out tests. When you go to production, you have to install it. You have to install your own SNOWSTORM server. It's Apache too, so there shouldn't be much of a problem. So as I was saying before, in the SNOWSTORM X version, it supports several terminologies. We know that it's an Fire API. So the native API is only for SNOMED, but the SNOWSTORM X can use any other. It has scripts that allow you to load certain terminologies like LOINC or ICD-10 also, or even your own local codes. If you have a text list, you can include that within SNOWSTORM, and you can ask SNOWSTORM and make searches. Now, obviously, for local codes or for ICD-10, there's no ECLs. Those queries are only for SNOMED. So each terminology has its own characteristics, and SNOMED is a little bit more complex. Therefore, it has a more complex API. If you go to the basic native API, this is the training software. SNOWSTORM training is one of the public servers that allows for people to play around with it. And this is the native original API. And there are several things here that you can take a look at in more detail. One of the most classical within concepts, the one that says branch concepts. Here you tell it where you want the concept to be looked for, active, for example, and for example, the word asthma. And then you go here, you try to run it, and immediately you have the outcomes. You have a history of asthma, and it has so many asthma caused by wood dust, a light or mild asthma. So this is also in ECL. You can also make a restriction here. For example, let's use the international version. Let's delete this one. Let's say that I only want to search for the descendants of clinical findings, not the one that says situation, but only the ones that say disorder. So I can put that ECL here, only the clinical findings with the word asthma. And then what you would expect is that history, for example, is no longer there. And if you take a look, we can look for it. We can go all the way to the end, and we can say that it's 253 in the original one. And then I can ask it to look for it again. And we can see that the first one is the same. But the second one, it's it's another disorder, and instead of 253, now it's 152. So it's about 70 that were discarded, that were no findings nor disorders, other part of the hierarchy. So this is an example of how it can be used to restrict. The URL of this request is this one, and you can copy it and you can paste it here on the top. And we can see the same thing. This is the same result. You can a plugin that allows me to see this, and this is the SNOWSTORM server. This is the SNOMED ECT, SNOMED CT. This is the concept. Here it says active concepts. And I know that it's a little bit small. You might not be able to look at it well, but this is the term that I was looking for. And this is the the ECL, and how many results it's got to pull. So you can put that in any application, and it's very simple to develop an application that simply consults this, because the complexity is in installing your own snowstorm, but having it like this is really easy. Now, the fire part of it, it doesn't have a swagger, but it does have a postman. So let's take a look at the fire details, and then we'll go and test the postman, and we can contrast them. So when using one and when using the other, when using the Fire API or the SNOWSTORM API, Fire is the one that's recommended because when you have accessing a third-party terminology server, if you want to be able to change the terminology server, you can start with SNOWSTORM because it's easier. But maybe I want to buy the Australian Onto server. They have all of the support and syndication and things that you like. And let's say that you want to install that one. And since the Onto server is Fire and SNOWSTORM may also Fire, when you want to change server, you just change the address and it's the same language. That is to say, same search, the way of executing them. It's the same interface. So it gives you quite a lot of a versatility using the Fire API. That helps you to solve or to work with the server the best possible way. If you use more than one code system, aside from Snowden, if you have other coding, other terminology, you will probably need the amplifier because the native is only for Snowden. And then if you want basic operations, there are some that are more complex, like customization or maintenance, that are not in the Fire API. So if you want that, you need the native. But if not, you can use Fire. And SNOWSTORM allows you a little bit more management and also attributes that are particular for different concepts. You can extend the terminology. It's a little bit more powerful, but only for consumption purposes. They are both very similar. Now, there is a little more information on the SNOWSTORM site, and there's another one here for development training. And this is like a course which explains how to install SNOWSTORM, how to have the SNOMED version, etc. So as I was saying before, there is a public instance, which is this SNOWSTORM training, and there's a local instance that you can install. You can download it and install it. When you go access, the public one is this one. If you download this and you install it, it'll be installed in your own computer. If you don't change the ports or any other setup, you will have the local host 8080. That's the server where it will be available. And once it's installed in your computer, you have to download the release files and import them within SNOWSTORM. And to import the release files, there are two ways of doing it: the command line or the REST interface. The release files can be downloaded here from this site where you can select what country you are in. That allows you to have an account. We have all of the countries here at the bottom. It gives you a free account. Then you register, you download the zip, and there you have the contents. And that file, which is this zip that you can see here, is installed either from their server using the command line by giving it enough memory, and you can run the jar, which is the SNOWSTORM, or you can use the REST interface, and there with that you need to do the updating of the files, and all of that is here in admin, or maybe it's in code systems. In one of these, I'd have to look at it in the manual, but in one of these we have these APIs that can be used to have the version. Maybe this is restricted in the training. Yeah, that's exactly what it is. When you, this is read-only. When you install it, you will have more options here. And one of them is import, and that will allow you to import these files. And with that, you will have a local server, which is like the international one. You can import the full, the snapshot, or Delta. Full has all of the changes, a snapshot, the latest version, and Delta has the changes for the last version. In general, it's the snapshot, then the Delta to add on top of it. And it takes about 1 hour to be available after the full import. This is when you do it from the command line. Here you have the Java SNOWSTORM 4.5. You're Yes, no, I am. I am. Let's see. You should see a screenshot of the command line. Is that right? Okay. Sorry, I apologize. But it's an example. It's not really the website. When you run it from the console, then you can see this. This is what you can see. This is the sentence that I showed before, which is minus minus import, and this is the output of the console. And well, the REST interface is what we just saw before. So let us review Fire, and then we can play around with the Fire interface to close. Fire is a standard that you're well acquainted with, but the terminology is an important part. It's part of the main component. So it's a module, it's a Fire module. Here we have the terminology and all of the characteristics for the terminologies that are used in Fire. If you take a look at this in more detail, we will get to this model. This is the model on how the terminologies are represented in Fire. And having this model was very useful because it started normalizing many of the things that different terminologies did by themselves. So in the past, we used to see, for example, LOINC, CD10, and we have a similar structure. This is something that is new. We used to have the previous versions, and this is the first one, the first time that these attempts really catch on, and it's one way of representing all the different terminologies. But each terminology is a code system. SNOMED is a code system, and each code system has different versions. So since CD10, for example, has a different versions, CD9, CD10, CD11 will be very different, but the CD10 has annual revisions, and each of those are what we would call a version. SNOMED has different versions too. These are versions that go through a module or per country, Uruguay, Argentina, and then it's a SNOMED Argentina July version. So these are versions of SNOMED with different terminologies. The same thing for the IPS that we showed before, that is for free. It's the same code system, but with a special version, which is the IPS version. These code systems are identified with a naming system. The IOD is the one that used to be used before from the Fire version 3, sorry, HL7 version 3. And in Fire, these SURIs are used. And it's called HTTP SNOMED Info SCT. That's what it is. That's or this IOD. The code systems have code, have displays, and sometimes definitions. The code, well, is the number that identifies the term, and display is the term itself, and then it has designations, relationships, but in principle, it has these that is common for all. And the code systems, I mean, you don't have access to all the code system, but to different value sets, which are sets, and they all have a value set. But the expansion and search operations are done through the value set. So for a code system, you can have lots of value sets because it has contents of a part of a code system, and they can be mixed. And sure, that can happen, but we're not going to go into that. And then we can do the concept map of the different value sets from SNOWMED, for example, that's represented. So terminology has code system, value set, and concept map. These are the three most important classes here. Now, when you have the definition, which is a file resource, for example, in abstract search, we use element definition. Those definitions are basically within a value, there is a SNOWMED concept, and there is a terminology binding field that is the link, which is done through the value set. This value set allow for the binding between the resources, which is part of the information system, and the code system. Here we have, for example, diagnoses. They are all descendants of findings, and so on and so forth. Here we have professions, and then we have all of the descendants. So those CCLs define the value sets, and the value sets define the possible element definitions. And when you have an instance, a FHIR document with a patient name, etc., there's a code, which is a code system, and that code has got to put the restrictions for that binding that the element has carried out. So here it says all of the different types of diagnosis. So here we have a pneumonia, and if it's okay, it says that it's okay. And if I put here appendicitis, then it gives me an error. So that's more or less the way that it's managed by FHIR, but there are operations here also. The code system has a lookup, which is one way of looking for a code and finding all of the details for that code. It also has a way of validating the code, whether that code exists or not. It also subsumes the children or the descendants of that code. But what we mostly use is the value set, which are expand and validate code. Expand brings all of the members of the value set, and it tells us the validate code tells us whether it's there or not. So you can use a lot of expand for the search, and then you can filter it. And if you get a code from elsewhere, you can ask if it's a medication. So onto the medication value set, you say, can you validate that? And if it says yes, it's a medication. And if not, then it's something else. And also the concept has an important function, which is translate, and that allows for coding between different terminologies. And the data types, there are three different data types that are complex to understand at the beginning, but these are coding, and codable concept. Code is the minimum. Coding is a code, but with a display, and a codable concept is a structure that allows for having different codings within it. An example. This is the codable concept for the diagnosis. And here it has a text, and it has different codings, two codings in this particular case. So it depends on how the clinical record sets it out. So if it uses only SNOWMED, it would probably say polyp of gallbladder, and it would have probably the same text. So in this case, we have a text that says gallbladder polyp. And we have two code. One is done with SNOWMED, which is polyp of a gallbladder, and then another one from ICD-10, which is other gallbladder diseases. So this is for the same clinical entity, we can allocate different types of codings, and they are not necessarily equivalent. It's just the best or most similar one according to the different types of terminology. So these two things are not the same, but it's the best ICD-10 coding for this text, and the other one is the best SNOWMED coding for that same text. The REST API is the one that we're going to be using in the Postman. And here it uses a get, post, put, and delete. Get is what we use the most, and some post for more complex operations. Another detail on how we can find things. When we want to communicate with an amplifier, we have to say what version we're looking in. And for a certain version, you use the SNOMED URI, which it gives us a particular version. And this one here, the first one is like the most basic one, info bar SCT. But as a version, I got to go into the lower one. So when you use CCT with a module here, which is the SCT ID, that's where you can start identifying. So here in the international version, you can see this number, which is the module code for the international version. Australian, this other one. Swedish, this other one, and so on and so forth. Now, so there's also another way. Instead of referring to the version from Uruguay, you can have a specific version from Uruguay. So if it's the November or the May version, and you can do that adding to this URL the version and the timestamp. So these are the Australian version, same module, but here you can see that this is 2013 and this is from 2012. So these are different versions in time for the same Australian version. And we will soon see how this is done. And let us go to the postman. I will share this with you, by the way. So the first thing that I have here, hold on, let me share the postman because I can see that I've not shared it. Tell me if it's too small when I start sharing it, please. Is it too small? Yes, it's very small. How about there? Is that any better? Is it better? Yes, it is better. I mean, I'm using a large screen, so. Yes, you can see well. Okay, it's a little bit larger there. So, as I was saying, let me go one back. There. Okay, let me close some of the tabs. These are different SNOMED collections. All of these instances have this variable. So we're going to start testing it with one server. And the other thing here is that the browser server, which is SNOWSTORM Fire SNOMED tool, has a different version, and some things change here and there, but you will find that out. But let's see. These are all of the examples: code, system, value set, concept map, but I wanted to take a look at some very particular ones. So for example, here where it says a base URL refers to this. It's precisely this text here, this value. So what it does is that it asks snowstormfiresnowmedstool.org what code system it has, and these are all the versions here. The Argentinian version, and we can look at all the versions. Well, for example, we can look for ICD. You will come across, it doesn't have ICT. These are all the SNOMED versions available. And this version is the one that is used when you want to search for a version in particular. So this is the 2004 version. But here, for example, if we change to the other server, which is the development one, which is for SNOWSTORM X, and I do the exact same query, you can see that it's very similar, 136 terminologies. But if I search for ICD, here you can find ICT 10, and the URL is this one here, which is the 2019 COVID expanded version. So we can look at what terminologies are available within the server to see where the values are coming from. Now, we can take a look here in SNOWMED. Let us go back to the demo. And in SNOWMED, we can say, let's go to value set. And within the FHIR terminology module, we're going to look at the value sets. And I'm going to do an expand, which is the expansion of a value set. And that expand, we have different parameters, URL, how many, and the filter. URL says which value set in particular I want to use. And here we use a shortcut because there are two types of value sets. Real value sets that are created that have a particular ID, and also the value sets that are called intentional. The other one are called extensional. Intentionals, it's just a logic terminology. They are defined with a query, and this is the query. This is the query of the descendants from SNOWMED. If I put that within the browser, which is this one here, and you can run it, you can see that we have what, 7,000 concepts. Sorry, I put it in the browser. I'm sorry, but you can't see it. But you can put that in the browser. So if I run this, it's going to expand to all of the descendants from this clinical finding, and it'll bring the first 10 and the ones that have asthma or terms that are similar to asthma. So it's run it, it went to the server, and we have 178 results. Now, if instead of asthma, I were to put here chest pain and search, you can see chest pain, dull chest pain, upper. So that's the way that SNOWMED searches. And it's only diagnosis because I have this here. If it's a part of the URL, that's precisely what defines that this value set will have the descendants of clinical finding. Now, if here I change this and I only wanted to bring me 2 results, there's another parameter called offset. I can put here offset, and I can also write 2. Then this will, if I have 2, we will have chest, wall pain, and upper chest pain. If I put this in 0 and I asked it to bring me 4, it's going to bring me the 4 that we've seen before. Chest pain, dull chest pain, because it tells me that there are 50, but I can see 4 out of 50, and then I can put the next, and then take a look at all of the pages with all of the 50 results. That's the way that it is used. Now, if we look at a similar example, but in Spanish, in this case, I'm saying not to search for international, but to look for the Spanish edition, the Spanish version, which is this ID module, and to look in the April 2022 version. But it's the same operation. And the language is Spanish, designations or descriptions in Spanish, and that it does not include the details. But the filter here is also in Spanish, asthma, but in Spanish. So here we have mild asthma, allergic asthma. The SNOWMED search are very, very powerful. If I write that, you will find, for example, thoracic pain, toradol, and it's not the same aura. So you can see that these just makes it sometimes easier. It doesn't have to be in the right order. It doesn't have to have the accent marks in Spanish. So that's the way you search in SNOWMED. You can change the query and restrict the search to smaller areas in SNOWMED, each time more and more specific. One other thing that you can do is to obtain a map. For example, concept map here. The object concept map. We were using variation before. So here we operation translate, and the parameters are translate this code. If I look for it in the browser, you're not going to see it, but I can. This code is asthma. So let's continue with the same example. So this is asthma in SNOWMED. So to look for it within SNOWMED and to give me the result in the target of ICD-10. For this version of SNOWMED, I can run that and it tells me that asthma in ICD-10 is J45.9, and that's done with translating the concept map in FHIR towards ICD-10. If I want to find more ICD-10 details, I can get the code system, which is identified with the URL of ICD-10. I can search for that and it tells me where it is. But if I want to find all the concept, let me change it. If I want to find all the concept, there. It tells you that ICD-10 has all of these details, the name, the title, the hierarchy. But if I want to find all the ICD-10 content, the first 50, it tells me A00 cholera, A00A09 intestinal infectious disease. So all of the ICD-10 coding are here. But if I want to look in ICD-10, I search for the same expand and with a filter. So here I have value set expand with the ICD-10 URL with an implicit value set. That's what this means, that it's equal to all the concept. And I add something here that the filter is asthma. And the first concept is J45 asthma or J45-8 mixed asthma, and so on and so forth. So I am searching within a different terminology, and the way of searching is the same as when I used SNOWMED. That's the interesting thing. If you take a look at these, they are both very similar. Let me close some of these that are here in the middle. This is the one that we're looking for. And again, ICD-10. Here it is, system code display. It's the same thing. So you can look for different terminologies with one terminology model. And depending on the language, you can say expand, offset, count, and filter. And here you do the expand to the SNOWMED URL with this filter here. It's basically the same thing. So it's very good for you to use. The same thing for LOINC. You can say, I want to take a look at all of the LOINC context, is an expand with the LOINC URL with certain restrictions, or you can say, I want to look within LOINC the terms that have, for example, glucose. So that's what I wanted to show, how SNOWSTORM as an open source server allows you to use SNOWMED, and you can have this querying, but you can also have other terminologies. And the advantage of when you're having a terminology server in a clinical system is that you can use it with FHIR, and you can see how you can simply change the server. And this is the SNOWSTORM. And we could have an auto server, we could have a Hermes, and the consultation is always the same parameters, and the results are pulled equally. And this allows us to have a lot of stability when coding all of that. That's what I wanted to share with you today, and I know that we've come up to time, and I can give you the presentation later on. Now, if I may, just 1 second to show you just one additional thing. I can see something pending here, some questions. This part of the interface, this is an example of like as if it were a clinical record here. So here you can see the extra data, what queries being used, and also you can search for diagnosis. Here, for example, asthma, we can here, for example, asthma resolve. We can also look for procedure, for example, excision of breast, and when it's when there is possible laterality, you can put it there. And on the back, it's used with SNOWSTORM or terminology server. So you can search for this and you can use this in GitHub. And it's available for you to use it, to play around with it. It's a very nice example of a medical clinical record that is totally modeled using FHIR terminology. That's it. Thank you. Maybe we have time for one question if there's any. Marcelo was asking, should I declare the implicit value sets on SNOWSTORM to produce the expansion response through the ECL constraint? Exactly. The SNOMED URL, there's a possibility of adding as a parameter of the URL the definition of that implicit value set. And when you add it immediately on the spot, you are defining the value set. It's not saved within SNOWSTORM. When you do the query, you define it dynamically by adding that query as part of the URL. And then you can change it and it's registered as a permanent value set. It's something that is dynamic that you can search for it all times. Thank you. Thank you for that answer. I had that doubt. So for the resets, I can save those as a declaration in the server with its corresponding content, and these implicit value sets are like resources on demand. They're not processed in the memory. They run the ECL, and then the ECL gives you a result. Sure. And then the first time that you use it, you will see that it's a little bit slower, and then it goes into the cache memory. And now the ECL also, as we saw the descendants, it has one that is like a little hat, and each when you use this as static, it always has and if you can't find it, you can search for them. You can run an ECL that is executed on demand, but which refers to a ref set that has been persistently used in SNOMED. So, for example, members of primary care ref set. So that's done in the ECL, and you can use these implicit value sets. I know that it's a little bit complex, but after a while, it's easy to understand. Yes, I understand. Thank you. Are there any additional questions? I do have an additional questions, if I may. ECL is an expression constrained language from SNOMED. I mean, it's not part of the FHIR standard. Yes, it's from SNOMED. And that means then that we must use SNOWSTORM that already has the ECL embedded, or can I make my own implementation that respects the ECL syntaxes for the FHIR server to be able to understand it? That's right. You have to do your own implementation. SNOWSTORM did it, and AutoServer too. All of the FHIR implementations that I showed already have them. OntoServer, for example, which is used in Australia. And if I had two terminology services for different purposes, maybe they are even solving different layers. But let's say that we have one with SNOWSTORM, and in the other one we have one for ICD-10 or others. Then the translation of the resources, the translate concept map, how are they integrated? Well, SNOWSTORM means that you don't have to choose two. But translate is something that is persistent in the server. You can have a translator in ICD-10 and not have it in the server. It's like the lookup, it's a step later that can be done in the second server. It's like a translate is translated on the concept map, and the concept map is explicit. So if I get a snowstorm and I put this snowstorm, and with that I can do a lookup of snows, and then I have the mapping let's say that we do this separately, and when having the mapping of SNOMED to ICD-10, that is translated, and then you can carry out the translate, and there it just gives you the code. And if you want to know what is the term of the code, then you have to do a lookup. And if you put ICD-10, and then you can do a lookup. But if you have it outside because you have it elsewhere, let's say in a WHO server, which is not FHIR, you can do the lookup in the other server. You define whether your terminology is going to be. Is that new, of being able to receive then the IC10 in SNOWSTORM? Yes, it is new, because I asked before and it only supported the SNOMED terminology. Right, it's precisely the reason as to why the SNOWSTORM X was used. It includes the other terminology. What I showed you before was a SNOWSTORM, but it's the X version. Can you remember that you saw that I was changing the server? They're not fully integrated, but X has a security for just about everything now. There's another question here that I will answer. All the training cycles will remain in the Raxel site. On courses here in the Moodle, you can, in this particular case, it's asking me for my user, but we've also enabled to log in as an invite. We have the latest one also uploaded, and this version will also be uploaded. It'll be available for you to check them, and also the next ones that are coming, and obviously all of the previous ones in the case that you were not able to log in or be a part of a session. So with that information, then I hope that I've answered your question, Ronnie. Remember, is here in courses. So time's up, and I want to thank Alejandro from the Regional Public Good and from LACPAS. We are working on moving forward with SNOMED as one of the strategic partners of these projects. So most likely, this is not the last time that we will come across Alejandro in these kind of sessions. So thank you once again for attending, and have a great weekend. And if we don't see each other again, well, happy holidays. Thank you, Carlos.
Feliz año, feliz fiestas.
Chao, gracias.
Gracias.